Okay, I wanted to do another example of finding the solutions to a quadratic equation that has complex roots. So we'll have x squared plus 6x plus 17 equals 0. You can also think of this as f of x, so some function of x. But we're trying to find out what values of x make this thing go to 0 from a complex standpoint, because if you tried to find the real zeros of this, you would find out it doesn't work. So how would we do this? Well, we just do it the normal way of completing the square. So we would say x squared plus 6x. We'd move this 17 over here. You take the 6, the coefficient in front of x, you divide by 2. 6 divided by 2 is 3. Square that, so that would give you 9. So what you do is you add 9, and you'd also subtract 9. Balance that out. Now these three numbers can be rewritten as a complete square, x plus 3 squared. And then these can be combined, which would be 8 plus 8 equals 0. Now, we would subtract 8 from both sides. And normally we would say, well, we can't find any real roots, but now we know that there is such thing as complex roots. So we would go ahead and take the square root. So we'd get plus or minus the square root of negative 8. Now the negative part of this is I. So we could write this as plus or minus the square root of 8 and then have I outside. So you could break off negative 1 separately and make that into I. And I just realized I took the square root here. So, okay, so we took the square root. So the left-hand side just becomes x plus 3. And then to solve for x, we're going to subtract 3 from both sides. So we'll end up with negative 3 plus or minus the square root of 8 times I. So that's our complex solution. So there's two complex solutions. There's negative 3 plus the square root of 8 I, and x equals negative 3 minus the square root of 8 I. Now we can simplify this by rewriting the square root of 8 as the square root of 4 times 2. You can simplify these things if the number inside the square root is some perfect square times another number. So 8 is 4 times 2. 4 is a perfect square, so the square root of 4 becomes 2 outside the square root, and then we're left with the square root of 2. So finally the answer is negative 3 plus 2 square root of 2I, and x equals negative 3 minus 2 square root of 2I. So these are the solutions to the original expression. What are the values of x? Where you can plug those into your original quadratic equation and get 0. Which we haven't done, so let's actually do that, just so you can see what goes on here. So let's take one of these. So how would you do that? So we square that, so it would be negative 3 plus 2 square root of 2I squared plus 6 times negative 3 plus 2 square root of 2I plus 17. So I'm just plugging it in the original equation. Okay, then we can use FOIL on this one. So let's do that. Negative 3 plus 2 square root of 2I times negative 3 plus 2 square root of 2I. So if we multiply this out, first you'll get 9. Negative 3 times negative 3. Then we'll get outside, it will be negative 3 times 2, which is negative 6, square root of 2i. So that's the outer. Then we'll get the same thing, negative 6 square root of 2i for the inner. Negative 3 times 2 is negative 6. And then you multiply these together. So you'll get plus 2 squared, square root of 2 squared, I squared. So you get 2 times 2 is 2 squared, square root of 2 times square root of 2 is square root of 2 squared, and I times I is I squared. Okay, so that's just multiplying out this thing here. Let's simplify before we plug it in. So you're going to have 9 minus 12 square root of 2i. And here we'll have 2 squared, which is 4, square root of 2 squared, which is 2, so that'll be 8, plus 8 times I squared. This is negative 1. So you get 9 minus 8 is 1. So you get 1 minus 12 square root of 2i. Okay, so now I'm going to go back over here and replace that initial term with that. Now if I multiply the second term out, I'll get negative 18, negative 3 times 6, plus 12, 2 times 6, 12, square root of 2i, and then finally plus 17. So we'll get 1 plus 17 is 18, minus 18 is 0. And negative 12 square root of 2i plus 12 square root of 2i is 0i, which is 0. So you can see that this is one of the solutions. And its complex conjugate is the other solution. So if I plugged in negative 3 minus 2 square root of 2i squared plus 6 times negative 3 minus 2 square root of 2i plus 17, I'd also get 0. So that's how it's shown to be a solution to the equation. And both of these are complex numbers. Now these are the solutions. So what are the factors? How would I factor that original equation? How would I show it as a factor? So x squared plus 6x plus 17. Was it plus 17? Yeah. So you have x squared plus 6x plus 17 is going to be equal to this factored solution. And the way you do it is slightly different than I said previously. But you could take these zeros and do this. You'd have x minus the zeros. It's essentially the same thing. So you get x minus one of the solutions and x minus the other solution, like that. So that would be the factored form. And then you could, if you wanted to, you could distribute this negative sign. So it'd become x plus 3 minus 2 square root of 2i. And the next one would be x plus 3. And then you have negative times a negative, so it'd be plus 2 square root of 2i. And that is the factored version, the complex factored version of this quadratic equation. Okay, I'm going to do another one. So let's say we have x squared plus 8x plus 27. is the function. The question is, what are the values of x to give you 0? Now, I've specifically chosen this to be an even number because if I had an odd number, then I'd have fractions as well, and we don't need to get that complicated. So we're going to complete the square. So we take 8 divided by 2, square it, 4. Actually, let's change this to a negative because we haven't done one with a negative yet. So this is going to be negative. This will be negative. Negative. So this is negative. That's negative squared. It's still positive. Plus 16. Plus 16 minus 16. Balance that out. You can make this into a complete square, so you'll have x minus 4 quantity squared. 27 minus 16 is 11, so you get positive 11 equals 0. Move the 11 to the other side. That's a negative 11. Okay. We're going to take the square root of both sides. So we get on the left-hand side x minus 4. On the right-hand side we get plus or minus the square root of negative 11, which is plus or minus the square root of 11i. So the negative 1 becomes I. The square root of negative 1 becomes I. And then we can add 4 to both sides. So we'll get 4 plus or minus square root of 11i. So we have two solutions, 4 plus the square root of 11i and 4 minus the square root of 11i. So those are my two zeros. If I plug either one of these into the original equation, I'll get 0. The imaginary parts will cancel each other out. All the real parts will cancel out. You'll have 0 plus 0i left if you do either one of these. Now to rewrite the original equation as a factored version, again, you'll take x, you'll put a subtraction, and then you'll take this one, put it in parentheses, 4 plus the square root of 11i, close parenthesis, and x minus 4 minus the square root of 11i. And that multiplied together will give you x squared minus 8x plus 27. And you can see if x is equal to the negative of this, then this goes to 0 and you get a solution. And finally, if you wanted to multiply this thing or distribute the negative, you would have x minus 4 minus the square root of 11i and x minus 4 plus the square root of 11i is equal to the original one. Now usually we keep them in this form because this form you got 3 parts to it. So you can't use FOIL, you'd have to use something more complicated. But let's just prove that this works out. If I multiply these together, I should get back to x squared minus 8x plus 27. So we're going to use this, and we're going to use FOIL. So this is the two terms, this one and this one, this one, that one. So first is going to be x times x, so you get x squared. Outer is x, so you got x times negative this thing. So it's going to be negative x times 4 minus the square root of 11i. So that's outer, x times negative 1 times 4 minus the square root of 11i. Then you'll have the inner, which would be negative x. So you get negative x times 4 plus the square root of 11i. So that's inner. And then last is going to be negative times negative, which is positive. And you'll have 4 plus the square root of 11i times 4 minus the square root of 11i. Okay, next thing we're going to do is we're going to multiply these terms out, the inner and outer terms, the outer and inner terms. So you'll get negative x times 4, which is negative 4x. Negative x times negative square root of 11i, which is going to be positive. The square root of 11x times I. So that's negative x times negative the square root of 11i. Then you'll have the next one, which will be minus 4x. So you get minus 4x, and then negative x times plus the square root of 11. So it becomes minus the square root of 11x times I. Okay, so that's these terms. And then we can use FOIL on this. So you can have 4 times 4 plus 16. The inner and outer cancel out because you've got 4 square root of 11i and minus 4 square root of 11i, so we can just put 0 because this is the complex conjugate of that. And then you have the last, which is going to be negative, positive times negative is negative, square root of 11 times the square root of 11, which is going to be 11, and then I times I, which is I squared. Okay, now look, notice here we have plus the square root of 11xi, and here we have minus, did I forget something here? Oh, yeah, plus the square root of 11xi and minus the square root of 11xi. So these two cancel out. So what do we have left? We've got x squared. We've got minus 4x, that's negative 8x. And then we've got 16 minus 11i squared. Well, I squared is negative 1. So this whole thing here becomes plus 11 because you've got negative 1 times negative 11, it's positive 11. So you got 16 plus 11, which is 27. And that should be what we started out with. X squared minus 8x plus 27. So you see it works. So that is about as complicated as we're going to get. But it goes through the same procedure as we normally do completing the square. It's just that we changed negative 1, square root of negative 1 into I. And also notice that the solutions here, the complex solutions are always complex conjugates of each other. And it needs to be that way because the original equation doesn't have any imaginary numbers in it. So you're going to have a complex conjugate answer so that the imaginary parts cancel out in the long run.